Big breaking. Brain experiments prove we have no free will. Your free will might not be as real as it seems. According to recent scientific discoveries, when you decide to pick up your phone, that decision may just be an illusion of free will. Studies indicate that your brain makes the decision for you half a second before you consciously recognize it. This challenges the idea that we truly control our actions. The question of what drives the brain's electrical activity becomes even more complex when we explore the nature of consciousness. Consciousness, which gives us the feeling of free will, requires deep investigation. Two well-known neuroscientists, Christoph Koch and Giulio Tononi, have attempted to understand how consciousness emerges in the brain using advanced scanning techniques such as fMRI and PET. They developed the integrated information theory, which predicts that the brain must process more information than it initially receives. Experiments confirm this, revealing that the brain generates more data than it takes in, leading to the creation of thoughts and ideas. Their research identified 4 key brain areas responsible for logical thinking, learning from past experiences, sensory perception, and bodily awareness. Studies suggest that consciousness is not merely a byproduct of electrical activity, but a complex phenomenon involving sensory perception and interaction with the environment. The rubber hand experiment demonstrates how the brain can create a false sense of reality by associating sensations with an artificial object. This highlights that consciousness is not just a collection of data, but a holistic experience shaped by our body and surroundings. Data plays a crucial role in understanding consciousness, and in today's world, data science skills are becoming increasingly valuable. Learning about tools like Python and machine learning can help individuals prepare for industry demands, opening doors to career growth and opportunities in top companies. Returning to the question of consciousness, understanding its true nature requires not only scientific research, but also philosophical reflection. Consciousness acts as the operating system of our brain, shaping our perception of reality. To grasp how it emerges, we must explore its fundamental aspects and underlying mechanisms. As life evolved, organisms began to develop self-awareness, recognizing themselves as distinct entities. This marked a significant step in the evolution of consciousness. Warm-blooded animals started exhibiting more complex behaviors and interactions with their surroundings, not only reacting to stimuli, but also remembering past experiences and their consequences, giving them an evolutionary advantage. With the emergence of mammals and birds, consciousness became even more intricate. These creatures developed social structures and communication skills, requiring a deeper understanding of their environment and fellow beings. As a result, their ability to learn and adapt improved, enhancing their survival and reproduction. Research suggests that consciousness is not a static state, but a dynamic process that continues to evolve. This raises profound questions about our perception of free will. How real is it? If consciousness and behavior in animals and humans are largely shaped by evolutionary mechanisms, are we truly making choices, or is free will just an illusion created by the brain? Understanding the evolution of consciousness can help us gain insight into how we make decisions and how our actions are shaped by both internal and external influences. This opens new avenues for research in neuroscience, psychology, and philosophy, allowing us to better comprehend human existence and our place in the world. Some scientists propose that quantum phenomena might influence our perception of free will. At the quantum level, randomness and uncertainty may play a role in decision-making. It has been suggested that quantum processes in the brain could create conditions where conscious choices are not entirely predictable. Studies reveal that while the brain processes information in highly complex ways, many of our decisions are driven by subconscious mechanisms before we are even aware of them. This means that, despite feeling in control, our actions may often be predetermined by internal processes beyond our conscious reach. Experiments like those conducted by Benjamin Libet suggest that free will might be an illusion crafted by intricate neural activities. This challenges traditional views of decision-making and raises deeper philosophical questions about human existence. If our choices are primarily dictated by unconscious processes, what does that mean for the true nature of free will? Quantum mechanics further complicates this discussion, implying that, at its core, reality may be far less predictable than we assume. This opens new possibilities for understanding how we perceive ourselves and our decisions in a universe where free will might not be as absolute as it appears. Recent research suggests that microtubules in our brain, which play a crucial role in neural communication, may exhibit quantum properties such as entanglement. If true, this could mean that something beyond traditional biochemistry influences our consciousness and decision-making processes. If microtubules indeed behave as quantum structures, this might explain why some aspects of consciousness and perception appear unpredictable or random. It could also shed light on the nature of free will, as quantum effects may introduce uncertainty into our thoughts and actions. Studies published in 2024 have provided experimental evidence supporting the presence of quantum characteristics in microtubules, opening up new possibilities for exploring the link between physics and consciousness. These findings could revolutionize our understanding of how the brain functions and how decisions are made, challenging conventional beliefs about free will and determinism. In light of these discoveries, we may need to rethink what it truly means to be human and how we perceive our choices in the broader context of the physical laws governing our consciousness. Quantum phenomena such as superradiance have been observed in microtubules formed from protein structures, where scientists have also detected quantum entanglement. This supports Roger Penrose's hypothesis that our thoughts are not simply the result of pre-programmed processes and highlights the role of quantum mechanics in shaping consciousness. Research suggests that superradiance occurs in microtubules when they interact with specific molecules, demonstrating the complexity and multi-layered nature of brain processes. This challenges conventional ideas about free will, implying that our consciousness may be influenced not only by biological, but also quantum factors. However, further experiments are needed to confirm these observations and verify the presence of quantum properties in microtubules. This highlights the ever-evolving nature of science, continuously raising new questions and expanding our understanding of consciousness. Scientists also emphasize that consciousness is not a singular entity, but consists of multiple independent modules. For instance, the right hemisphere of the brain is responsible for visual perception, while the left hemisphere processes verbal information. This functional division explains why we can sometimes recognize objects but struggle to describe them accurately if the relevant brain regions are not connected. Additionally, neuroplasticity allows the brain to adapt and reshape consciousness through learning and experience. This means that subconscious processes influence conscious decisions, and by understanding these mechanisms, we can enhance our quality of life. By becoming more aware of our thoughts and actions, we can train our subconscious mind to make better choices. Thus, exploring quantum consciousness opens new pathways for personal growth and self-improvement, enabling us to leverage scientific knowledge to enhance our lives and achieve our goals.